Hello everyone, my name is Amareshwar Reddy and I am from CSE department. Today my topic is about airline gate allocation system. Introduction to airline gate allocation system. The airline gate allocation system is a system that decides which gates at an airport should be used for incoming and outgoing flights. Its main goal is to make sure that gates are used in the best possible way so no flight has to wait unnecessarily for a gate. It also helps prevent two planes from being assigned to the same gate at the same time, which could cause delays. By managing gates efficiently, the system helps the airport run more smoothly. Passengers get a better experience because flights arrive and depart on time, and airport staff can handle operations more easily. Importance of gate allocation. Proper gate allocation at an airport means assigning the right gate to each plane at the right time. When this is done well, flights leave and arrive on time. If a plane has its gate ready when it lands or before it departs, there are fewer delays. Planes don't have to wait for an empty gate, so schedules run smoothly. No gate clashes. Sometimes two planes might need the same gate at the same time. Proper planning prevents this, avoiding confusion and delays. Faster aircraft turnaround. Turnaround is the time a plane spends at the gate for passengers to get off and on, luggage handling, refueling, and cleaning. Efficient gate allocation makes this process quicker because everything is ready in advance. Better safety and happier passengers. When gates are managed efficiently, airport operations are safer since planes are not moving around unnecessarily on the tarmac. Passengers also experience less waiting and fewer missed connections, making the journey more comfortable. Key components of the system. The first one is the flight schedules and real-time data. The system needs to know when each flight is supposed to arrive and depart. Real-time updates are also important because sometimes flights are delayed, arrive early, or get cancelled. This helps the system adjust gate assignments dynamically. Second one is airport layout and gate capacities. Each airport has a limited number of gates, and some gates can only handle certain types of aeroplanes, for example, small versus large planes. The system also knows the distance between gates, taxiways, and terminals, which helps in making assignments more efficient and convenient for passengers. Third one is algorithms and optimization models. These are computer methods or formulas that help decide the best way to assign gates. The goal is to avoid conflicts, two planes wanting the same gate at the same time, and reduce waiting or taxing time for planes. For example, if flight A is arriving at 10 a.m. and flight B at 10:05 a.m., the system finds the most efficient gates so that neither flight blocks the other. Types of gate allocation strategies. First one is manual gate allocation. This is when human airport staff or controllers decide which flight goes to which gate. They rely on their experience, knowledge of the airport and the current situation like delays, early arrivals, or maintenance works. In simpler words, people decide the gates based on what they know and see at that moment. Second one is automated gate allocation. This method uses computer programs or algorithms to automatically assign gates to flights. The system looks at flight schedules, gate availability, and other rules, then chooses the best gate. It can do this quickly and handle many flights at once. A computer automatically picks the best gate for each flight using rules and data. Third one is hybrid gate allocation. This combines both methods. The computer suggests the best gates, but humans can review, adjust, or override these decisions if something unusual happens. It brings together speed and efficiency from automation with human judgment for tricky situations. In simpler words, computer gives suggestions but people make the final call when needed. Optimization techniques used. First one is linear programming (LP) and integer programming (IP). These are mathematical methods used to make the best possible decisions. In the case of gate assignment at airports, LP and IP help decide which flight should use which gate so that everything runs smoothly. Linear programming is used when decisions can be split into fractions, like assigning half a resource, while integer programming is used when decisions must be whole numbers. You can't assign half a gate to a plane. Second one is heuristic and meta-heuristic algorithms. Sometimes there are too many flights and gates, making it very hard for mathematical formulas to find the perfect solution quickly. Heuristic methods are like shortcuts. They don't always give the perfect answer, but give a good enough solution fast. Meta-heuristic methods, like genetic algorithms or simulated annealing, are smarter shortcuts that explore many possibilities to get a solution very close to the best one. Third one is handling complex constraints. Real airports have lots of rules. Gate compatibility. Some planes are too big for some gates. Turnaround time. Each plane needs enough time at the gate for cleaning, refilling, and boarding. Priority flights. Some flights, like international ones, may need special gates. LP, IP, and heuristic methods consider all these rules when assigning gates so that no flight is delayed and gates are used efficiently. Challenges in gate allocation. Okay, constraints in gate allocation. Handling peak traffic periods with flight volumes means dealing with times when many flights are arriving and departing at the same time. This is tricky because there are only a limited number of gates and resources at the airport. If too many flights need the same gate or runway at once, it can cause delays or confusion. So airport staff and systems need to carefully plan and manage everything to keep operations smooth. Managing irregular operations like delays and cancellations adds another layer of difficulty. Flights can be delayed because of bad weather, technical issues, or air traffic problems. Balancing fairness among airlines and operational constraints is about giving all airlines a fair chance to get good gates or time slots while also considering real-world limits. Benefits of an effective gate allocation system. First one is aircraft size and gate compatibility. Not all gates can fit every plane. Big airplanes need larger gates, while smaller planes can use more gates. This means the airport has only certain options for each flight. Turnaround time requirements. Planes need time at the gate for unloading, cleaning, refilling, and boarding new passengers. The schedule must make sure each plane has enough time or delays could happen. Third one is airport policies and airline preferences. Airports have rules about which gates can be used for certain flights, and airlines sometimes prefer specific gates for convenience or efficiency. These rules and preferences affect which gates each flight can get. Technology and software solutions. First one is reduced aircraft taxiing time, which saves the fuel and lower emissions. When airplanes spend less time moving on the ground between the runway and the gate, they use less fuel. Improved punctuality, better satisfaction. When flights leave and arrive on time, passengers experience fewer delays and inconveniences. Airlines also benefit because keeping schedules, making operations smoother and builds trust with customers. Third one is better resource utilization, more airport capacity and revenue. Efficient use of gates, taxiways and runways means more planes can be handled without overcrowding. Case study about implementation at a major airport. Modern gate allocation system work closely with other airport systems like airport management systems, which handle overall airport operations, and flight information display systems, which show flight details to passengers. This connection ensures that gate assignments are always up to date and coordinated with the rest of airplane operations. Future trends in gate allocation. A big international airport started using an automated system to assign gates to airplanes. Before this, gate assignments could be messy, especially during busy times, causing planes to wait or fight over the same gate. With the new system, the airport was able to reduce these gates clashes by 20%, making it smoother for planes to park the takeoff. Key performance indicators KPIs. Artificial intelligence AI and machine learning ML will make gate will make gate assignments better. AI and ML are computer systems that can learn from past data. In airports, they can study patterns like flight delays, busy times, and gate usage. Using this information, they can suggest the best gates for incoming and outgoing flights automatically. This means fewer mistakes, fewer conflicts between planes, and smoother operations. Challenges in implementation. The first challenge is gate utilization rate. This measures how well the airport is using its gates. If gates are often empty, the rate is low, meaning the space isn't used efficiently. Second one is average turnaround time. This shows how quickly an aircraft can be prepared for its next flight, including uploading passengers, refilling, cleaning, and boarding new passengers. A shorter turnaround time means the airport is efficient and can handle more flights with the same gates. Third one is on-time departure and arrival rates. These indicate how reliable the airport and airlines are in keeping flights on schedule. High on-time rates means flights are leaving and arriving as planned, which reflects a smooth operation and good coordination between gates, staff, and aircraft. Finally, the conclusion of this topic is high initial investment costs like makes setting up new technology or systems at an airport can be very expensive at the start. Resistance to change among staff, people working at the airport may be used to the old ways of doing things, ensuring data accuracy and system reliability. For new systems to work well, the information they use must be correct and up to date. If the system makes mistakes because of wrong data or if it crashes often, it can cause delays, errors, or even safety issues. Reliable and accurate data is essential for the system to succeed. Thank you everyone for listening my presentation.